Welcome to our channel. In today's video, we are excited to introduce a powerful new feature in Indox, our Retrieval Augmented Generation or RAG system. With the integration of Neo4j, Indox can now harness the power of graph databases for more advanced and context-rich information retrieval. Indox is a RAG system designed to provide fast and accurate answers to complex questions by combining natural language processing techniques, machine learning, and now graph databases. Initially, Indox used traditional vector stores to represent and search for information, but we've enhanced this capability by introducing Neo4j to capture deeper relationships and context between data points. Traditional vector stores rely on linear relationships, making them less effective at capturing complex, multifaceted relationships between entities. By integrating Neo4j, Indox now models data as a network of interconnected nodes, which allows for more flexible and precise queries, helping us understand the context and relationships between the data, which leads to more accurate answers. Let's take a look at the overall workflow in Indox when using Neo4j. First, we retrieve a document like a Wikipedia page, for example, and then we split the content into smaller chunks. Next, entities and relationships are extracted, and these chunks are converted into graph nodes and edges. Finally, the graph is stored in Neo4j where it can be queried to provide rich, context-driven answers. Now let's dive into a quick demo. First off, we need to install a few libraries that would help us run our demo. These include Indox, Neo4j, Wikipedia, and a few others that will let us fetch data, split text, create embeddings, and connect to our Neo4j database. Now that our libraries are in place, it's time to set up some environment variables. I created the .env file to securely store my API key and database credentials. It keeps my sensitive info safe and out of the main code. Here I load our env file, which allows us to easily access those stored variables like Neo4j URI and username and password. Let's check if everything loaded correctly by printing out the Neo4j URI. Great! Now we're ready to grab some data. We'll use the Wikipedia reader class from Indox to fetch some content. For our demo, let's pull in some information about Queen Elizabeth I. We'll just grab the first 500 characters so we have a nice bite-sized chunks to work with. Now that we have our text, it's time to break it down into smaller and more manageable pieces. This makes it easier for our system to handle it. We'll use the semantic text splitter to split the text into chunks of 50 characters. Next up, we need to turn those text chunks into embeddings, which are basically vector representations of the text. This is super important for understanding the relationships between the chunks. Here, I'm using a pre-trained Hugging Face model. Now comes the fun part. We're going to convert our text chunks into graph documents. This is where the magic of graph databases comes in. Using LLM Graph Transformer class from Indox, we'll take our document chunks, apply our embedding model, and organize everything into nodes and relationships for using Neo4j. We'll also add some metadata like the title and source, and here let's get to it. Want to see how our documents look? We can print them out to get a sneak peek at how the entities and relationships are structured. You can see that we have chunk nodes that sort our the embedding for text chunks, and also nodes of person type, country type, and relationships with source and target nodes, and also the type of the relationship. Here it's time to connect to Neo4j and add our graph documents. We'll use the Neo4j graph class to set up our connection, and then we'll add the documents we just created. It's a pretty straightforward process. Now that our graph is live in Neo4j, let's see what we can find. We can search for relationships between entities. For example, let's check if there are any parent-child relationships related to Queen Elizabeth. This will give us some interesting insight. Yes, we can see that we have two parent-child relationships for Elizabeth. After this, let's take things up a notch. We'll use a vector-based question answering. I'll show you how to set up a search that let us ask questions and get answers based on our graph data. For instance, let's find out who was Elizabeth I. Here is, we can see the answer. We can see that the information is based on our limited data because we fit the model with just 500 characters of the Wikipedia page. Next, we can also perform a keyword search and combine both methods in a hybrid search for more accurate results. Let's run a quick test on both so you can see how each of them works. This will really show the flexibility of our setup. Finally, we also perform a hybrid search using the AJT class. This combines the best of both words, vector and keyword searches, so we can get the most accurate answers. Let's see how it works. Since we fit the model with limited data, we can see that it was not able to find the relevant document, so it goes to search the web to provide an answer. With Neo4j, Indox now delivers deeper and more accurate insights through advanced graph-based queries. Whether you're handling complex relationships between entities or simply need more context in your answers, Neo4j in Indox provides a flexible and powerful solution. To try it yourself, check out our demo code and subscribe to our channel for more tutorials and updates.